Converting data into powerful insights is one of the most important skills in the current age of AI. The market size is estimated to be about 300 billion US dollars. And on an individual level, it is estimated that your chances of getting a promotion or higher salary increases by 40% if you have the skills on how to convert data into insights. So in short, if you are able to master the skill of converting data into powerful insights, you are playing a multi-billion dollar game. Welcome to this master class on data to insights. Converting data into insights is a complex challenge, and to truly master it, you must first master the thought process behind it. So in this video, I'm going to train your brain on how to go from data to insights. We'll be starting with defining on what is data insights, and then I'll be explaining you a data to insights framework which will help you master this thought process behind converting data into powerful insights. I'll be also explaining this framework with a very concrete example, and then we will conclude with some key takeaways as well as call to action. So let's get started with this topic of what is data insights. The world currently has 182 zettabytes of data, and by 2028, the global data creation is expected to surpass 394 zettabytes of data. Now, simply speaking, this is roughly equal to 98,500 billion DVDs. And all this data is available in various formats such as tabular data, text data, video, photos, IoT sensor data, etc., etc. And data generation is happening all the time, and it is not that difficult. But the real problem is what to do with all this data. Can this data be converted into something interesting or useful? So data insights is discovering some interesting patterns within the data so that it can help us in our day-to-day life, or it can help an organization for improving its business. Converting data into insights is a complex challenge, and to truly master it, you must first master the thought process behind it. And I've developed this framework which is designed to help you build and strengthen this way of thinking. I'll be explaining on how to go from data to insights using this framework which you see on the screen. At the top, you have the opportunity or the challenges which are related to data insights. Even though converting data into insights is technically very interesting, it has to have some purpose. You should either leverage an opportunity or address a challenge. Opportunity or challenge means solving a specific use case. The use cases can be of two types: a business use case which is related to enterprise, or it can be personal use case. And examples of business use cases are customer analytics, supply chain management, or risk and compliance. And examples of personal use cases are personal finances, health analysis, and travel planning. Now, for all these use cases, you can convert data into insights using four broad types of analytics. The first is descriptive analytics, which is about analyzing the past or the current situation. In simple terms, this is understanding on what is currently happening. Diagnostic analytics is finding the reasons behind the descriptive insights. In simple terms, it is why this is happening. And predictive analytics is forecasting or predicting the future. In simple terms, this means getting insights into what is going to happen. And prescriptive analytics is recommending based on predictive insights. So if predictive analytics gives a positive outcomes, then prescriptive analytics is about the conditions which will make those positive outcomes possible. And if predictive analytics are giving some negative outcomes, then prescriptive analytics is how to stop those negative outcomes. And in order to do these four types of analytics, there are lots and lots of algorithms which are available. For example, for descriptive analytics, we have statistic, correlation, clustering, image processing, video processing, etc., etc. For diagnostic analysis, we have root cause analysis, target analysis, machine learning, explainability, causal inferencing, or reasoning. And for predictive analytics, you have classification, regression, time series forecasting, anomaly detection, or even survival analysis. And you can do prescriptive analytics using recommendation, optimization, simulation, what if analysis, and also recently very trendy, which is generative AI. And then at technical level, you can implement all these algorithms using multiple approaches such as no-code visualization, Python, or natural language interface. Now this framework will help you master the process on how to go from data to insights in a very efficient way. And for most of the use cases, we will have to apply multiple types of analytics as well as algorithms. And let me demonstrate this framework with a very concrete example. I will take the use case of customer retention, and let us first see on why customer retention is a huge business opportunity. Customer retention refers to a company's ability to keep its existing customers over a long period of time. It is about making sure that customers continue to choose product or services instead of switching to competition. And customer retention has got many benefits. Retaining customers is significantly cheaper than acquiring new ones. This reduces marketing as well as acquisition expenses. Loyal customers also tend to spend more over time, contributing to steady and predictable revenue, which also includes cross-sell and upsell opportunities. Satisfied customers also become brand advocates, driving word-of-mouth referrals that attract new customers and enhances the brand credibility. Now let's see the business case, meaning how much value can customer retention use case generate. Let us take an example of a telecommunication company which has got a customer base of 30 million customers, and let's assume that they have a retention rate of 70%, which means they have a churn rate of 30%. Now this equates to 21 million customers who are retained every year. And if we consider an average yearly revenue from each customer to be $600, this equals to a total revenue of $12.6 billion. Now, if we increase the retention by just 5%, that would translate to a yearly saving of $900 million per year. Now let's see the different type of analytics which we can use in this customer retention use case. The first is descriptive analytics can indicate the current retention as well as the current churn rate. As we are interested in decreasing the churn, the diagnostic analytics can show what are the root causes of the customers who are leaving. And predictive analytics is about predicting if a customer is going to churn or not churn. And prescriptive analytics is what actions we need to take in order to reduce the churn and thus increase the customer retention. Now let's see this use case in action where I'll show you on how to apply all these different type of analytics. But first let us look at the data. The data has got various fields such as the customer ID, the customer demographics, the services which the customer has, as well as all the billing details. There is a column churn which is an indication if the customer has left the company or is still with the company. And let us first start with descriptive analytics to better understand the current situation. And one of the very powerful techniques of descriptive analytics is clustering. We can apply clustering to group similar customers together. This will help us understand the different customer segments, and understanding the customers is the first step towards retaining customers. So shown here is the clustering results, and we can cluster all the customers in 3 segments or clusters, and each dot corresponds to a customer, and we can hover over the dots to see the customer details. You can also use cluster interpretation using a radar chart to understand what these clusters mean. So in this case, the cluster 0 is customers who are having the highest tenure, as well as their various digital services such as streaming TV, streaming movies and others. Cluster 1 is customers who are having low tenure and moderate usage of digital services. And cluster 2 is customers having low tenure and no digital services, and they have a very short-term month-to-month contract. Now another interesting descriptive analytics we can do is to analyze on what is the retention rate. And so shown here is a bar graph visualization giving the proportion of customers who have churned compared to those who have not churned. And you can see that the percentage of customers who are churning is almost about 30%, indicating that the retention rate is around 70%. Now let's focus on diagnostic analytics, where we can find out the reasons on why the customers are leaving. And let us start with our target analysis, which is analyzing the different features in the data with relation to the target, which is churn. And here we have a stack bar graph which shows this contract type and the proportion of customers who have churned. And we can see that customers who have a month-to-month contract or short-term contracts tend to churn more compared to customers who have long-term contracts such as yearly or 2-yearly contracts. Now here we see a box plot which is analyzing the tenure versus churn. And from this visual, it is very evident that customers who have a low tenure tend to churn more. Shown here is an analysis of monthly charges. You'll observe that high monthly charges are also reasons to churn. Now, based on these insights, we can make the following observations. The customers who have less tenure are likely to churn. High monthly charges are also reasons to churn. And customers with short-term contracts also tend to churn. Now, let's go to predictive analytics, and we can use machine learning to predict customers who are likely to churn. The machine learning model is trained using dependent variables, also called as X, such as demographic fields, types of services, and billing fields. And the target is Y, which is churn. And the machine learning model will try to make a relation between X and Y. And the machine learning results can be visualized as a confusion matrix, which is shown on the screen. It compares the model's predicted classes with the actual classes, helping to visualize the accuracy of predictions. And it has got 4 key components. The true positive is where the model is correctly predicting the customer who have churned. The true negative is where the model is predicting customers who have not churned. The false positive is the model is inaccurately predicting churn where actually the customer has not churned. And then you have false negative, which is where the model is incorrectly predicting no churn where the customer has actually churned. Now it's time to make predictions using this machine learning model. And for example, here we see a customer which is shown on the screen, and this customer is predicted to churn. And this prediction can be explained with visualization which is shown. We can see that the top factors which are contributing to churn are the low tenure, the short-term month-to-month contract, and the total charges. This explanation also matches with the descriptive insights. Now let us look into the prescriptive analytics. Once we know which customers are likely to churn and its reason, we can take actions to avoid the customer leaving. In the previous example, we know that the customer is predicted to leave because the customer has got a low tenure and it has got a temporary month-to-month contract. Now, if you remember descriptive analytics, where we have grouped all the customers in 3 clusters. Now, this particular customer belongs to cluster 2, where the customer has got a low tenure as well as short-term month-to-month contract. Now let's also look at the bar graph, which shows the number of customers who are predicted to churn across all these 3 different clusters. And we can see that the customers are predicted to churn across all the 3 clusters, but the most of the customers who are churning belong to the cluster number 2. So in order to reduce the churn, we can send marketing messages to the customers based on the cluster to which they belong. The cluster 0 is digitally engaged customers. A marketing strategy could be to create digital loyalty cards and reward them based on use of digital services. The cluster 1 are moderately engaged customers with a low tenure, and a marketing strategy could be to offer them discounts or convert them into long-term contracts. And the cluster 2 are customers with low tenure with short-term contracts. And a marketing strategy could be to educate them about advantages of digital services and excite them and convert them into long-term contracts. So you can see that these 4 types of analytics are not independent from each other. And we have used a combination of all types of analytics to create this customer retention strategy. Now let me go to the last layer of the framework, which is around techniques. And let me focus on some Python code as well as natural language approach to execute all this analytics. Let us see the Python code for predictive analytics related to machine learning. You can easily generate a Python code which will give you a machine learning model capable of predicting churn. So the Python code can be generated using various large language models, and one of my favorite is DeepSeek. You can write a prompt such as, I have a Python data frame with numeric and non-numerical columns, and also it has got a target column. And I like to use numeric and non-numerical columns to predict the target using machine learning. Please give a function which takes the data frame, target column and returns the model. And voila, in a while you'll have the Python code generated with all the detailed explanations. I'll not waste your time in explaining all the details, but you can see that coding has now become very simple. In the recent age of agentic AI, we can also use AI agents to convert data into insights. And let me show you a demo. I can ask a question to this telco data just in plain English and in a chat mode. For example, I can ask a question such as, what is the proportion of churn versus non-churn? And the AI agent will give me insights based on my questions. I can even ask advanced questions such as, make a clustering with 3 clusters, and the agent will come back with the clustering results as well as a very nice visualization. So this is really powerful. It can enable anybody to convert data into powerful insights. Now let me conclude this video with some key takeaways and call to action. Data to insights is a challenging task, so it is very important to have a framework which will help you master the thought process of converting data into insights. Data insights is technically very interesting subject, but it is very important that it should lead to a value either by leveraging an opportunity or solving a challenge. The 4 types of insights are very useful as you have seen. However, it is very important that you think of all these 4 types of insights in a very coherent way and look for opportunities on how to combine them in order to address the business use case. Now let's go to the call to action. All the analytics which I have shown in this video are also available on my platform experienceddatascience.com, and I recommend that you can apply all this learning of this masterclass on your own data using my platform experienceddatascience.com. You do not require coding skills, so that you can just focus on applying data to insights thought process in mastering the topic. Alright my friends, I'm hoping that you have enjoyed this video. If yes, do not forget to subscribe to the channel, like and comment on the video, and see you soon in another exciting video.